VNN Canada with me, Navedna Prabhu. On today's special episode, I'm joined in by Dr. Azad Kaushik, who is a professor of immunology. He's going to be talking to us about something that the entire world is going through right now. Of course, it's COVID-19, but what is it looking like in terms of the medical sector and, of course, the impact on economy? He's going to be talking to us about that and much more. So, Dr. Azad Kaushik, thank you so much for taking the time out and joining us on VNN Canada.
Thank you, Nivedna, for having me. I'll be happy to share my thoughts on COVID-19.
Right. It is a testing time for the entire world. The entire world has never gone through a global pandemic of this sort where everything is being tested at the moment. My first question to you would be, over the couple of months, how have you seen the development and what are your key takeaways from the same?
Okay. Well, first of all, let me say it this way, it's a long time. It's not for the first time that has happened in the history of humankind. The last pandemic we had was in 1918. There was Spanish flu. And I also remember that in the century previous to that, there was bubonic plague that had swept across Europe. And it even wiped 1/3 of the total population at that time. So it's just that our generation, through many, many generations, we are seeing this kind of pandemic at this time. Well, coming to your question that when we spoke last time, at that point of time, there was so little known about this. It was not even declared a pandemic by WHO at that time. What we knew was that there's a new virus that has come, and that is not unusual because new viruses, they keep coming every year. Like we get new kind of flu virus every year, and these viruses, what we call new viruses, they undergo lots of mutations. Yeah. Mutations is like changing their surface proteins or changing their dress, in simple words. So those kind of things we always get every year. But what has happened and why it is a pandemic is that this is a virus against which 100% of the world population, more or less, is susceptible to this infection. Something like this never existed. So our immune system has not been primed against this virus. So all of us are susceptible, and only those who are recovered out of it, they would have a primed immune system to be either able to protect for a certain period of time against this infection. So what has happened from during those times, now we know quite a few things about this. We have some controversy with regard to the origin of this virus. One of the thoughts is that, well, it's a bat virus because it has a very high DNA sequence similarity with the bat virus. Right. And so bat coronaviruses have jumped into humans. That is one thought that exists. Well, the DNA sequence of this virus has also come out now. And there is some kind of controversy with regard to that. The thought is that, this virus has some HIV genes in there. It is very unusual, and HIV causes AIDS.
Right. Yes.
And why should there be a gene of AIDS virus in a bat coronavirus? That's a big question. In fact, you're talking to me at a time that in 1984, HIV AIDS virus was discovered. And I have also looked at the DNA sequence, and this is true. There are some HIV elements in the DNA sequence of this COVID-19. The person who discovered HIV, Nobel laureate Luc Montagnier, he is also suggesting that, well, in nature, this HIV gene cannot get into a bat virus. This is very unusual.
Yes.
And one of the thoughts is probably that this was generated in laboratory, and somehow it escaped from a laboratory and has spread across the world. Yeah. So it has a very unique kind of structure that makes all of us susceptible to this. And also, in fact, that this virus is able to infect very strongly. And why it can infect strongly is that you see that this virus gets inside the cell by joining a protein on the surface of the cell.
Yeah.
And that protein is called ACE2.
ACE2.
ACE2, yes. And this ACE2 protein is involved in blood regulation. And this is widely distributed. It is present in respiratory tract, the brain, the intestine, the lungs, the kidneys. It's almost throughout the body, even in our nose, in our nasal entrance, the mucosa, the surface of the nose, basically. So all these places are rich in ACE2 receptors. So this virus finds a home easily inside the human body because ACE2 receptors are easily accessible. So it starts residing in the nose and throat, and that's from where it spreads through the body. So its spreadability is very fast. And apparently some of the people who have no symptoms whatsoever, they would be carrying this virus and passing it on to others. And even those who recovered from COVID-19, they would be transmitting this virus to others up to 3 weeks at least.
Okay.
So the spread factor is very high in this case, and the virulence is very high.
In terms of the vaccine and the conversation that has been happening about it ever since this actually took over the world in a way, what are your thoughts on that? What do you think about the vaccine? Do you think that is the only solution for this pandemic?
Well, yes. When we spoke last time, I mean, it was not declared even a pandemic at that time.
Right.
Okay.
Yeah.
So, pandemic would basically mean that a large population, in this case, almost 100% of the population is susceptible to this infection. Now, because herd immunity, you have to have a significant population to be immune to this virus. Only then we can develop some herd immunity that the chances of people coming in contact with somebody who is carrying COVID-19 virus would be low if it is herd immunity, because there are a lot of immune people who don't have the virus, so you can mingle freely. So you have to have a significant population here that is immune to this virus, and that can happen only after people got infection and they recovered out of it.
Right.
Now, there is a demographic situation, as we spoke last time. The younger population is not getting a severe kind of disease. Many of them don't even have symptoms of the disease. They would have some changes, small changes like simple taste or smell that would change.
Yeah.
And it will be mainly the elderly population, as we are seeing in our nursing homes, the loss happening there. And those people who have these chronic diseases and those who have some kind of immunodeficiency, they'll be more susceptible to this in the younger population. Right. So essentially, this virus is spreading from asymptomatic individuals to others. And also those who have recovered from COVID-19 infection, fortunately, they are able to carry this virus and spread it to others up to 3 weeks. So that's a long time span. So the chances, and that is why we have this lockdown that is containing the spread of this infection. And so this lockdown is essential in that sense until we have a vaccine. And vaccine is a challenge. It takes about 1.5 to 2 years. But the fact is the technology is pretty advanced. And we have around 70 companies around the world in race for developing a vaccine at this time.
Right.
The professor from Oxford University in UK, who is at a very advanced stage at this time. And I'm told that there are some human clinical trials that are going on very soon, or they have started already. So they are planning to have some vaccine by fall. But that's probably a kind of, I would say, being very ambitious about it. But it might take longer. But one thing is very clear, that COVID-19 is here to stay. And it is going to change us for a good period of time until we have a vaccine that comes out.
The last time we did, when we spoke, of course, it had just started around the globe, and like you said, it wasn't declared as a pandemic, but there were reports about it being called a biological weapon. And at that point of time, you said no, there is nothing, of that sort. Would you still stick to that statement?
Well, let me tell you, this is very difficult to prove. This is because the thing is, the technology that we use to create new vaccines,
Right.
it is the same technology that is used to either insert a new gene or to delete a new gene,
Right.
or to make a virus more pathogenic, more harmful in some ways.
Right.
So this would, let me say it this way, it would be very, very difficult to prove it either way. There's an evidence to suggest that there's a very high DNA sequence similarity with the bat coronavirus. So that is one argument that goes in favor that, well, it's a bat coronavirus that has jumped from bats to other species and humans. And normally, let me say it this way, this coronavirus is not confined to humans. It spreads, it circulates through bats, birds, dogs, cattle, cats. So it is all over actually. And as they pass through these different species, they undergo mutations. So it is very, very difficult to say that it was generated in the laboratory. Okay, so that is one point of view, I would say. One point of view. The second point of view is that certainly there's a possibility that biological warfare weapons can be developed easily given the knowledge and state of technology at this time. But
Right.
having said that, what we do know in case of this COVID-19 is that there are some inserts or kind of gene products that would make a protein. And that kind of insert is coming from HIV.
Okay.
HIV is a virus that causes AIDS. By the way, it was discovered in 1984. And I have seen the DNA sequence myself.
Okay.
And there are some HIV like inserts in the DNA, which is very unusual for a bad coronavirus to have one, or how it happened in the nature is a big question mark.
Yeah.
And I do know that Professor Luc Montagnier, who discovered HIV in 1984, he has made a statement that this COVID-19, those HIV inserts, they cannot happen in nature. And I would agree with him on that. And so apparently this has been created in the laboratory. But somehow, maybe they're trying to make a vaccine against HIV. That's one possibility. And in that process, somehow, this virus escaped from the laboratory. So that's another possibility. But apparently, it has the characteristics like harming such a huge population around the world, characteristics of what a biological warfare weapon would look like.
Okay. In terms of the economy, what do you look at in that aspect? It's affected it entirely, whatever sector we're talking about, whether it's trade, tourism, businesses. How are you looking at that? Do you think we can bounce back, as a society in terms of the economy? And how soon?
Well, that's a very good question. But you see, this is a battle between two aspects of human life. One is health, the second is economy. And so, is health going to win over economy, or is economy going to win over health? The trouble is the economy the world over has come to a halt.
Right.
And I understand trillions of dollars have been put in to get the economy going. This is a very unusual kind of situation. Now, if you see, we have checked the spread of this COVID-19 in Ontario and elsewhere by this lockdown. By checking the movement of the people, we have been able to control it to a significant to a significant point. But still, you see that what has happened in our nursing homes in Ontario and Quebec, that you would figure out that the virus is still somehow finding its ways to get to the susceptible population and causing a loss to life. So the thing is, if we open up the economy, then those are the kind of consequences that COVID-19 would spread pretty fast to the population. And again, we might have to. And if we just keep the economy shut, for how long can you do that?
Right.
I mean, there is after all a limit to everything. So the best way would be, what I would propose is that we should identify and isolate. That should be our approach. Now, there's a Canadian company that has come out with a testing kit that it takes about 1 hour to identify those who are COVID-19 positive.
Right.
So that's pretty good. I mean, it doesn't take a day as the other classical methods do. So 1 hour is a good time. 1 or 2 hours, if you know somebody is COVID-19 positive, these individuals should be quarantined until they have fully recovered and are no longer carrier of the virus. And those individuals who are either recovered from COVID-19 or are COVID-19 negative, they should be allowed back in our essential services and to relaunch our economy in some ways. It has to be done in a very regimented way, that you really identify the geographical locations where economic activity can be started, where it cannot be. But COVID-19 is here to stay.
Okay.
It is here to stay. It may take years before we are in a situation to develop a herd immunity. Or the only way prior to that is if we have a good vaccine.
Okay.
And I do want you to know that there's a very good possibility of developing a vaccine, because some of the targets on virus that have been identified are immunogenic, means they are able to generate a good immune response. And we have the technology, and so there's a very good possibility that we would have a vaccine, but I just can't say it'll be 6 months or it'll be a year or a year and a half. So until that time, we have no choice but to identify, isolate and quarantine, and others can get back into restarting our life and economy. But it is going to change our lifestyle for a reasonably good period of time.
On that note, the last and final question would be, what would you like to tell people? The last time we spoke about it was on set, and you said the first thing you said is don't panic, because there was a lot of panic at that moment. So before I let you go, what are the key pointers that you would like to tell people who are tuned in right now?
Well, I would still stick to my point of view. Please don't panic. You would see here that the younger population in general, if they don't have any immunodeficiency or any kind of chronic disease, they would recover out of it. It will be like a flu that came and passed by. They would be carrier for some time. They have to keep distance, physical distance from others, and not to transmit virus to others. And after that, I think they can go back to relatively normal life.
Right.
So there's no reason to panic. That is one thing very clear. It is not a kind of situation that the curve has already flattened here in Canada.
Yeah.
It's flattening elsewhere as well. But these waves of this infection would keep coming in high density populations, or where there are carriers within the community who can spread this infection. So there's no reason to panic. But yes, we have to be very cautious. We have to protect ourselves, especially the elderly. And also those with chronic diseases or with already known immunodeficient kind of disease.
Right.
And having said that, I would say that we have to go on with our life. We have to, but we can't just be reckless at all in this. We have to be cautious. We protect ourselves, and we protect everybody around ourselves.
So those are the last words that you would like to give our audiences. And once again, thank you so much for taking the time out and giving us important points, because I think nobody really talks about why it's important not to panic during such a testing time, because we're not taught how to deal with this. So I think these pointers that you've given us are fantastic. And thank you once again for joining us on VNN Canada.
Thank you very much, Nivedna.